Hello, my name is Kolujana, and today I'll be discussing the problem definition and conceptualization of swinging or grappling in games. The main challenge in implementing swinging or grappling is achieving realistic motion while maintaining gameplay fluidity. There are three key issues. The first one is simulating accurate pendulum motion that reacts to player inputs and the environment. The second one is managing collision detection with objects or terrain during the swing or grapple. The next one is allowing dynamic attachment points, especially in open-world games. Developers need to balance realism with accessibility, ensuring that players feel in control while navigating complex environments. So, hinge joints are physical components that constrain movement to a single axis, mimicking the motion of a door hinge or pendulum. They are commonly used in games to simulate realistic rotational motion, which is essential for creating immersive gameplay mechanics. So here I want to show you an example of how hinge joints are used in games, creating games. So here, as you can see, multiple chains are connected to an anchor. An anchor is the point where all the hinge joints are connected to, and the anchor will attach to another body or the wall, and it will not move away or break apart from the attached object. So to the anchor, the corresponding chains are connected to it using hinge joints. So to understand how hinge joints works, we need to look at the physics behind them. So hinge joints, they simulate pendulum-like motion and are governed by rotational dynamics. Specifically, torque is a key factor. This formula shows how hinge joints create rotation. Additionally, forces like gravity and damping influence the swing arc, ensuring the motion stays natural. These principles form the backbone of hinge joint functionality, providing realism in swinging mechanics. In Unity, the hinge joint component offers several adjustable parameters to control motion. First, we have angular limits, which restrict rotation within a specific range, crucial for preventing unrealistic behavior. Next, motor settings allow us to apply forces that drive rotational motion, enabling dynamic interactions. Lastly, damping helps reduce oscillations, making movement smoother and more controlled. So these parameters provide developers with the flexibility to fine-tune hinge joints for various applications, from swinging ropes to mechanical doors. One of the most common applications of hinge joints is in swinging mechanics. For example, let's consider a rope swing where a player attaches to a fixed point. Here, hinge joints simulate the natural arc of the swing by leveraging angular limits and gravity. This setup replicates the real-world physics, making the player's motion feel intuitive and immersive. With proper configuration, hinge joints bring life to such mechanics, adding depth to gameplay experiences. Hinge joints also play a critical role in grappling mechanics. Once a player successfully grapples to a target, hinge joints anchor the movement, allowing for realistic pivoting. Combined with recasting, hinge joints enable dynamic attachment points, creating seamless transitions between grappling and swinging. For instance, in the grappling hook mechanic, hinge joints provide rotational freedom necessary for smooth and believable player movement. Let's compare hinge joints with other hinge joint types. Unlike fixed joints, which offer no rotational freedom, hinge joints allow controlled rotation around a single axis, making them ideal for swinging and grappling. On the other hand, spring joints add elasticity, which is great for bouncy effects, but unsuitable for pendulum-like motion. This comparison highlights why hinge joints are the preferred choice for creating smooth and realistic rotational mechanics. So while hinge joints are powerful, they come with challenges. Ensuring stable motion under varying forces can be tricky, and without proper settings, Jittering or unrealistic oscillations may occur. To optimize performance, damping can be used to smooth motion and reduce unwanted oscillations. Additionally, setting appropriate angular limits prevents erratic behavior, ensuring controlled and natural movement. By addressing these all challenges, we can unlock the full potential of hinge joints. To wrap up, hinge joints are indispensable for creating realistic swinging and grappling mechanics in games. The ability to simulate natural rotational motion makes them stable in game physics. With adjustable parameters and proper tuning, hinge joints can deliver fluid and immersive gameplay experiences. Thank you so much.